Okay, you guys. So the last homework you had was homework number 47, synthetic substitution, the factor theorem, and then solving equations, solving higher degree equations. There's a lot of material there. We're gonna spend a whole nother lesson on that, or a whole nother homework on that. But I'm gonna do some of the problems. I'm gonna do 4 of the problems from last night's homework, or not last night's, homework number 47. I'm gonna do 4 of those problems. And homework 48 is going to be very similar to this. So I'm going to work out those. Also, I'm sending you the answer key to 47 along with this, so you should be able to look and see how to do. I'm only going to do 4 problems. If you need to see any of the others, you can look at the answer key. It's going to be worked out in great detail. Okay, here it is. So I'm going to start off with page 375, number 7, and it's up there. Let me see. Let me get it going up there, and I'll write it. Yeah. Yeah, well, you could, either way, it doesn't matter because I'm going to do it right up here. So number 7 says P of x is 2x to the 4th minus x to the 3rd plus x minus 2. And they're telling you that C equals -3/2. Actually, they're not telling you it's a root. That what they're doing is they're saying, find the value of P of -3/2. Find what that is by using synthetic substitution, right? Which means you use synthetic division, the remainder turns out to be the answer. So here's how you do it. To find this, one way of doing it is to plug in -3/2 for x here, but then you'd be going -3/2 to the 4th power, -3/2 to the 3rd power. You'd be dealing with some ugly fractions. It's nicer to do it this way, okay? We do synthetic division, -3/2 is the root. Notice you do not change the sign because they're actually giving us the root. They're not giving us the factor where we have to change the sign to get the root. They are giving us the root. So we use -3/2 as our root. We use these coefficients here, 2x to the 4th minus 1x to the 3rd. Be careful. If you got this problem wrong on the homework, the most likely spot you got it wrong is you did not put a 0 in for the squared term. Make sure you put a 0 to account for any missing terms. So there's a 0 for the squared term. Then we have -1 to x. I'm sorry, it's +1. +1x and -2. So now you just do synthetic division. That consists of bringing this guy down below the line to multiplying. 2 times -3/2. Well, the 2 upstairs and the 2 downstairs cancel. You just get -3. Add those together. -1 and -3 is -4. Multiply that. Negative times negative is going to be positive. Notice it's like 4 over 1, so it's going to be 4 times 3 on the top, 12 on top, over 2 on bottom. That's going to be 12 over 2 is 6, which is going to go there. Then add those together. 0 plus 6 is 6. 6 times 3/2, again, that's going to be 18/2, which is 9. And it's a positive times a negative, which is a negative. So -9. And then 1 and -9 is -8. So I need to go -8 times -3/2. Well, negative times negative will be positive. 8 times 3 on the top is 24. Over 2 on the bottom is 24 divided by 2 is 12. So this would be a 12. So -2 and 12 is 10. So there you go. That's how this works. 10. The remainder you get when you do synthetic division is what the same thing you would get if you were to plug in for x and crank it out. It would turn out to be 10. So that's called synthetic substitution. There'll be a little bit more of that on the homework tonight. Okay. Now I'll go on to the next problem. The next one is number 15. Now this one's going to take some background information. Well, let's just start working on it. Okay, this is the kind, the factor theorem. This is where you don't want to do it by synthetic division and find the remainder. What you want to do is plug it in. That's what you're wanting to do when it says using the factor theorem. They're saying find the root that goes with that. What root goes with the factor of z minus I? Well, what would the value of z have to be to make this equal 0? So it'd have to be I take away I. So I is going to be the root. Okay, so that's the root that we're going to be plugging in. So we need to plug I into that equation, into this. Watch, P of z is z to the 7. Watch, there's a pattern here. Z to the 6, z to the 5, z to the 4, z to the 3, z to the 2, z, and a constant. So we got everything accounted for here. And the question they're actually asking is, determine whether this guy, z minus I, is a factor of this guy. That's what we're actually trying to find out. We're not trying to find out what you get when you plug I in, like P, what is P of I, but it is the same thing. But what you're trying to do is find out if it's a factor. The way you do that is you plug this value in, z minus I, so you plug I in for z and see if you get 0. If you get 0, it's a factor, because that means the remainder of synthetic division would have been 0, right? So if you do get 0, it's a factor. If you don't get 0, it's not a factor. Okay, so here's the deal. We're wanting to plug I into this. Now, before I do that, I want to go through something with you guys. This is going to be interesting here. Okay, in fact, I'll just do it right here. Okay, I'm going to look through the different things of I. There's I, then I'm going to look at what's I squared, I to the 3rd, I to the 4th, I to the 5th, I to the 6th, and I to the 7th. Because that's what we're going to have to be doing. Notice when we're plugging this in, P of I, it turns out to be I to the 7 plus I to the 6 plus I to the 5th plus I to the 4th plus I to the 3rd plus I squared plus I plus 1. That's what you get when you plug in I for the variable z. So now, what do all these simplify to? Well, first of all, I is just I. There's nothing you can do about it. I squared, what's the definition of I? I squared, what's the definition of it? It's -1. That's how you even know what I squared is, right? I squared is -1. I is the square root of -1. I is the number, when you times it by itself, you get -1. So that's what this is. What's I to the 3rd? Well, notice, I to the 3rd is just I squared times I. Well, I squared is -1, so it's -1 times I, which is -I. Okay. What's I to the 4th? It's I squared times I squared. Isn't I to the 4th I squared times I squared? Yeah. This is -1 times -1, which is +1. Okay. How about I to the 5th? Well, you know what I to the 5th is? It's just I to the 4th times I. But I to the 4th is 1. So it's 1 times I is I. So I to the 5th is actually the same as I. Okay. What's I to the 6th? That's going to be I to the 4th times I to the 2nd. Well, this is 1. I to the 4th is 1. I to the 2nd is -1. 1 times -1 is -1. And finally, I to the 7th is going to be I to the 4th times I to the 3rd. Well, I to the 4th is 1. I to the 3rd is -I. So it's 1 times -I, which is -I. So we just went through and figured out what I to all these powers are. And if you notice, there is a pattern. We could do this forever and ever. But if you notice, it goes through a cycle. It goes I, -1, -I, 1. I, -1, -I, this would be 1. I to the 8th would be 1. Then you go I, -1, -I, 1. And it just keeps repeating. Every 4 of them repeats the pattern. Yeah, interesting. That's how it works. So, what does this actually turn out to be now that we calculated what all these I to all these powers turn out to be? Turns out to be, look, I to the 7th, which is -I, right? Plus I to the 6th, which is -1, okay? Plus I to the 5th, which is I. Plus I to the 4th, I know that's 1. Plus I to the 3rd is -I. plus I squared, that's plus -1, and then plus I plus 1. That's what I get when I put all these simplified versions of I to the powers in for that. Now, look what happens when I start adding this stuff together. It's kind of tricky. Okay, negative I plus positive I. Those guys cancel. They wipe each other out. -1 and +1. They cancel each other out. They add up to 0. Okay, negative I and positive I. They add up to 0. -1 and +1 adds up to 0. Look, everything wipes out. This whole thing adds up to 0. And that means the question is it a factor? Yes, it is a factor because you get 0. If you get anything other than 0, it's not a factor. So yes, z minus I is a factor of that polynomial. How about that? Yeah, exciting, unbelievable, but very nice. Okay. Here's a straight up solving an equation. Now, until this section, we didn't have a way to solve higher degree problems than squared. You know, we had all the quadratic stuff. We could use the quadratic formula to solve second degree equations, but we didn't have a way to solve third or fourth. And actually, we're not developing a general way to solve third or fourth degree equations. Actually, they're kind of baby fooding at us a little bit. So I think you guys should appreciate that, because they're saying, how do you solve x to the third plus 3x squared minus 3x minus 9 equals 0? How do you solve that equation? Well, the answer is they're not really saying how do you, if they just ask that question, how do you solve this equation? I think your correct answer would be, I don't know. I'm not sure how to solve a third degree equation, and that would be a good, legitimate thing. I only know how to solve second degree equations. But guess what, little baby? You know what they're doing, little baby? They're actually saying, here you go. I know you can't solve this, but look, little baby, I'm going to tell you one of the answers that solves it. It's called -3. -3 is one of the roots. So I'm not just telling you to solve this. I'm saying solve this, but just to help you out, little baby, I'm going to give you a root, okay, that already works. And then you go, goo, goo. I can suck it out of this polynomial and knock it down to a second degree. Oh boy. So here's what you do. You take that root, -3. Remember, you do not change the sign because they're giving you the root. They're not giving you the factor, and you have to figure out the root that goes with it. They're giving you the actual root, okay? It's -3. This one should work. So we get 1x to the third, 3x squared, minus 3x, minus 9. Now, they told me that -3 is a root of that. So I better get 0. If I don't get a 0 there, something is wrong. Okay, so let's figure this out. Let's just do synthetic division. Bring down the 1. Boom. 1 times -3 is -3. Okay. 3 and -3 is 0. Okay. 0 times -3 is 0 again. This and this is -3. -3 times -3 is regular 9. This and this is 0. Cha-ching, cha-ching. Check it out. So remainder, constant, first power, second power. What I did is I pulled out the root that I knew was a root to that equation. I pulled it out of my third degree equation, and I knocked it down to a second degree equation. Let me show you. 1x squared plus 0x. I don't even have to really put 0x. You can put 0x if you want. I just leave it out if it's a 0. And then -3 is the constant, equals 0. The other two roots are hiding inside of that guy. So now you just have to solve this equation. You can solve any second degree equation by, at worst case scenario, quadratic formula, right? Maybe sometimes factoring. You could do completing the square. This one, I'll show you what I would do. Since x squared is by itself and there's no x term, I would add 3 to both sides, get x squared equals 3, and then square root both sides. Don't forget! That's right, those are minus. Yep. So we get x is plus or minus square root of 3. Don't forget the plus or minus, you guys. That gives you gives you both solutions. If you forget the plus or minus, you don't get the other solution. So there's the other two. This is the one they gave us. So if you look, the samples are up in the back of the book to see if you got it right. They're going to show the entire thing. They're going to show the root they gave you, -3, and then both of these, plus or minus square root 3. Cha-ching. And there you go. That's how that works. Okay, let's do one more. Yeah, yeah, you know it! Okay, we're going to do number 31, and that's going to be the last one I do from this assignment right here. So let me erase this, and we'll be on our way. So, all right. So we've got 3x to the fourth plus 5x to the third minus 7x squared minus 3x plus 2 equals 0. And they're telling us that both 1 and -2/3 are both roots of that guy. They're both roots of that polynomial. So I should be able to, if I take either one of those out, they should give me a 0 remainder, which is great. That's exactly what I'm wanting. Does it matter which one I do and what order I do them? No, it doesn't matter, but I'd rather do the nicer number. I'd rather do the integer number 1 before I do the fraction number. So I'm going to do the first one. I'm going to take the integer 1, I'm going to use that as my root, 1, and I'm going to put into synthetic division. So 3x to the fourth plus 5x to the third minus 7x squared minus 3x plus 2 equals 0. Okay, there were no missing terms, so I was looking for that when I was putting them in, just in case there happened to be any missing terms. I had to put 0, but there weren't any. So here we go. Now I'm ready to do synthetic division. Guess what? I'm expecting that to be a 0. It better be a 0. So bring this guy down. 3 times 1 is 3. Add those together. 8. 8 times 1 is 8. Put it there. Add those together, 1. 1 times 1 is 1. Add those together, -2. Multiply those, -2. Add those together, 0. Cha-ching, cha-ching, just like I wanted. Now, I hope you listened to me when I told you, when I was teaching the lesson for this, I hope you listened to me that you can do the other one that works, -2/3, right? That's the other root. You could do this, and you could use these same set of numbers right here from that polynomial up there. Use those same set of numbers. You'll get a 0. So you might think you're doing it the right way because you will also get a 0. Like, yeah, it was supposed to go evenly. But then you'll have, this will be a 3rd degree, and you'll have another 3rd degree polynomial that you have no idea what to do with. So you don't want to do that. What you want to do is knock this from a 4th degree down to a 3rd degree, because notice remainder, constant, 1st power, 2nd power, 3rd power. This is a 3rd power polynomial. What you want to do is take this root out of that 3rd degree polynomial, and it'll knock it down to a 2nd degree. And remember, any 2nd degree can be solved by worst case scenario quadratic formula. Okay, so I should do that. Now, this is supposed to be a root, so I'm expecting this to also be a 0. It should be. If not, there's a problem. So let's bring this 3 down, okay? 3 times -2/3, right? The 3 upstairs and 3 downstairs cancel. I just get -2. Okay? Add those together. 8 and -2. That's going to be 6. Multiply those together. That's going to be positive times negative is negative. Okay? 6 times 2 is 12 over 3 is 12 divided by 3 is 4. So it's going to be -4. 1 and -4 is -3, right? -3 times -2/3. First of all, negative times negative is positive. 3 upstairs and the 3 downstairs cancel. That gives you +2. This and this is 0. Cha-ching, just like I wanted. And now I have knocked it from a 4th down to a 3rd and from a 3rd down to a 2nd. So right now, remainder, constant, 1st power, 2nd power, I have a 2nd degree equation. It looks like this: 3x squared plus 6x minus 3 equals 0. Wait a minute. The good fortune is with me. Look at this. I could use A is 3, B is 6, C is -3. I could put that into the quadratic formula. If I do, I'm going to be dealing with some big numbers and a bunch of simplifying, extra simplifying at the end. So you can do it. It's not wrong to plug this into the quadratic formula. But what I would notice is, wait a minute, everything has a 3, right? So if I want to make it a little easier on myself and less reducing and deal with smaller numbers, I can divide both sides of that by 3. When I do that, look what happens. I get x squared plus 2x minus 1 equals 0. Holy moly, okay? Now, can you think of two things that multiply to be 1 and subtract to be 2? I can't. You might say, well, how about 1 and 1? No, they multiply to be 1, but they add to be 2. If that was a plus, then you could use 1 and 1. But no, there isn't two numbers that multiply to be 1 and subtract to be 2. So it doesn't work that way. So that means this, I'm going to have to use either completing the square or quadratic formula. I like quadratic formula, so that's what I'm using. A is 1, B is 2, C is -1. That's going to give me my other two roots. Okay, so here we go. Okay, here's how the quadratic. If you don't have the quadratic formula memorized, shame on you. Get it memorized. X is opposite of B, so -2, plus or minus the square root of B squared, 2 squared, minus 4AC, 4 times 1 times -1, square root of that whole thing, all over 2A, 2 times 1. All I did, I didn't even think. I just plugged numbers in for letters into the formula at this point, okay? Now, it's a matter of simplifying, and then I'm done. -2 plus or minus square root of 2 squared is 4. Minus and minus net out to be a plus, so it's going to be plus 4 over 2. 4 plus 4 is 8. So this becomes -2 plus or minus square root 8 over 2. Now, remember 8, square root 8 can be thought of as square root pretty and square root ugly. What's pretty? 4. What's ugly? 2. 2. So it's 2 root 2. So this becomes -2 plus or minus 2 root 2, the whole thing over 2. Oh my gosh, 2's everywhere. Have you ever seen so many 2's? That means we can do some canceling. Now, here's some mistakes people make. They try to just cancel those 2's and call it plus or minus 2 root 2 or something. That is not right. You can't just cancel these. These guys are stuck by pluses or minuses. They're married, right? You don't want to be a home wrecker, right? So you can't just do that. You have to factor out a 2. It has to be multiplied in order to do that. So what am I going to do? I'm going to say these guys both have a 2, right? So I'm going to factor this out. -2 divided by 2 is -1, plus or minus 2 root 2 divided by 2 is root 2, the whole thing over 2. Now, look, this is guys in his own apartment. These guys are this. Now you can cancel. These become 1's, and you get the great answer, -1 plus or minus root 2. These are the other two roots, -1 plus square root 2 and -1 minus square root 2. So how would you list it as the entire solution set? You would do it like this. You would say, okay, those two that they gave us to begin with, we already know, 1 and -2/3. We knew that from the very beginning, right? But now we could throw in these 2 numbers. Wait a second. Okay, it's going to be -1 plus or minus root 2. And notice that is 4 answers. This, and -1 plus root 2, and -1 minus root 2. That is 4 solutions. A 4th degree should have 4 solutions, and it does. Okay. That was that homework assignment. So I'll tell you what. So for this homework assignment, you're gonna get now, it's gonna be, that one was 1 through 19 odds and 31 and 30 something, I don't know what it was, but look at this one. 375, 2 through 20 evens, 30 and 32. It's just like homework 47, except for the even numbered problems. So it's gonna give you a little more practice with all of this. And all I can say is enjoy.